I've kept track of my car's fuel consumption over the past month. I observed the miles per gallon for 17 trips from my home to FIU. The average miles per gallon for the 17 trips was 31.1 miles per gallon with a standard deviation of 2.1 miles per gallon. Form a 95% confidence interval for my true fuel consumption when driving to FIU. To keep my gas budget in check, I need to average at least 30 miles per gallon. Based on the interval you just created, should I slow down? Okay, so let's look at the key phrases here. The first thing I want to identify is the phrase here that says, form a 95% confidence interval for my true fuel consumption when driving to FIU. So they don't say the word average here, but it makes sense that if we're talking about the true fuel consumption when driving to FIU, we're talking about my average fuel consumption for the journeys, right? And we're asked to form a 95% confidence interval estimate of that. So I know it's a confidence interval, and at that point I should use my 4-step procedure. So we're going to go ahead and say, step 1, record the data. Okay, so let's record the data from the problem, all the numbers that were given to us. So it says here that I observed the miles per gallon for 17 trips from my home to FIU. That means that N here is 17. It says the average miles per gallon for the 17 trips was 31.1. So now I know my X bar is 31.1. And it goes on to say that the standard deviation is 2.1 miles per gallon. So we'll use 2.1 here for my S, or standard deviation. Okay, and then finally after that, we're going to list the confidence level. The confidence level is 0.95. That leads to an alpha value of 0.05. And then from there, we can say that alpha divided by 2 is 0.025. Okay, so those are the items I have from the problem itself. Now let's do our step 2. Our step 2 is always going to be to get our critical table value. So the value that we find from one of either the Z table or the T table. Because of this sample size, n equals 17, that's going to indicate I should use T alpha divided by 2. It'll be a T table because the sample size is under 30. So when I go to the T table, I'm going to be looking up alpha divided by 2, that's 0.025. So we're going to look up 0.025. And then we're going to do that under 17 minus 1 degrees of freedom, or 16 degrees of freedom. Okay, so let's go to our T table now. Look up 0.025 under 16 degrees of freedom. Okay, so we're looking up 0.025 and 16 degrees of freedom. The 0.025 column is there, so let's isolate that. And let's go down to where we see 16 degrees of freedom. All right, and coming down then into that row, we see 2.120 is our answer. 2.120. Okay, so we found our table value to be 2.120. That's our critical T value. All right, from here, the rest of the steps are just formulas, so we just plug in the numbers into the given formulas. So step 3, we want to calculate the margin of error. That formula is E is equal to T alpha divided by 2, S divided by the square root of N. All right, and so the T is 2.120, S is 2.1, and we're dividing by the square root of 17. All right, so let's work that out and see what we get using the calculator. So we will have 2.120 times 2.1 divided by the square root of 17. Okay, so we end up with the answer. Approximately 1.079769, let's say. Okay, so I've rounded it off after several decimal places. I'm going to store that value into my calculator and then use it in the next step. So the next step that we have to work out is the actual interval itself. X bar minus the error, comma, X bar plus the error. And that's our final step to the process. So our X bar was 31.1. So it'll end up being 31.1 minus the error from step 3, comma, 31.1 plus the error from step 3. And when you're done doing that, you'll end up with the following interval. So it'll be 31.1 minus the error we had, and then 31.1 plus that same error. So the interval becomes 30.0 and 32.2. Okay, so that's rounding it to the tenths place. And now let's try to interpret our results, right? We usually write the statement, we are 95% confident that the true mean is between these two values, right? So let's write that out then. We are 95% confident the true mean fuel consumption, right, is between 30 and 32.2 miles per gallon. All right, now how does that relate to the question that was asked at the end? It said, to keep my gas budget in check, I need to average at least 30 miles per gallon. Based on the interval you just created, should I slow down? Well, when we look at this here, we see that the fuel efficiency or gas mileage that I will end up getting is somewhere between 30 and 32.2. So that's where I believe my average is located. Even in the worst case scenario, I'm averaging 30 miles per gallon, which means that I meet this requirement that I average at least 30 miles per gallon. So in that case, I'm doing well, and I can feel safe or feel that it's within my budget to make the commute. I don't have to slow my speed down or drive better to save gas.